All right. Well, welcome everybody to the Denver Amazon Web Services User Group meeting for May of 2020. My name is David McDaniel, aka Mac. I'm the Director of Cloud Professional Services at Quinix, as well as Anthos Practice Lead at Quinix. My contact information is here. We do have a Denver AWS User Group Twitter handle. And I actually did tweet the meeting out a few minutes before, and thank you for those who shared my tweet. I do want to let you know you can unmute and ask questions if you like, or send them in chat, either to everybody or privately, and I will do my best to answer all the questions. So the agenda for tonight, for those of you who have been here before, this should seem familiar. We'll go over some communication items. Upcoming meetups, I realized I have not updated because I have not planned the next months yet. So I am open for suggestions, requests, if anybody has any specific topics they'd like to see covered. Got some resources, and then we'll go ahead and head on to AWS Security 101, tools and services from AWS. As usual, our Slack channel is available. If you need some help, it's a great way to reach out and get some help from a number of people that have joined the channel. Somebody's saying that they can't see the slides. My fellow Quinix compadre, you're seeing the slides, right? Is anybody else not seeing the slides? I'm not seeing anybody else saying they're having an issue with the slides. Maybe try to resize your window, or try to drop and connect back on the Zoom meeting. I'll be sure to let you right in. Sorry you're having issues. We do have our Twitter handle, as I mentioned, as we are listed on the official AWS user groups for the Americas page. And if you do have any announcements, especially job postings at this point, please feel free to send them, and I'll post them up here so people can be aware of them. For the AWS updates for tonight, I was focusing mostly on security, so we got a fewer number of items. But the first is that CloudTrail simplifies its management and its interface, so it becomes easier to set up new CloudTrails. And for those of you who are wondering, CloudTrail is kind of an auditing tool in AWS. It's a service that allows you to record all AWS API activities that occur within your account. So it allows you to do some selection on what type of activities, but it's management activities. So things like creating an S3 bucket or deleting an S3 bucket. It's not for things like what happens on your EC2 server or in your Lambda. AWS SSO has introduced zero downtime certificate rotation. So if you're using the AWS SSO service, which is their single sign-on service, it enables you to federate single sign-on activities. And it is the SSO IDP, the identity provider. So you can actually integrate other services into Amazon's SSO and use Amazon's IAM as your identity provider, which can be really nice especially if you don't have any on-prem Active Directory infrastructure to federate to. Work mail flows now enable you to scan emails inbound or outbound using Lambda. So you can do DLP or look for specific content in emails going in and out of your work mail accounts. Direct Connect has an enhanced monitoring now, so it gives you better visibility into your Direct Connect performance and availability. And for some of you who might be wondering, why is this a security thing? Because private connectivity is very important to a good security posture. So making sure that your private connectivity is always available is important to security as well. Macy has been enhanced and about 80% reduced pricing. So Macy is a tool, as we'll see a little bit later, that allows you to scan your S3 buckets for sensitive information. AWS Fraud Detector now is enabling you to catch fraudulent activities quicker. And things like registering multiple accounts and following certain patterns that are typically utilized by fraudulent activity is now identified quicker in Fraud Detector, and allows you to react in a much more quickly, which is always a good thing. So you're not finding out days later, you're finding out minutes or hours later. A couple tools that I've found over the years, and all these are links. So when you get the PDF, I will publish the PDF and the video for this later. And when you get the PDF, you'll be able to click on these links. I hate providing links that everybody has to type out 300 characters. So the policy generator is basically an IAM policy generator that was built by somebody else outside of AWS, open source on GitHub, and it's actually better than AWS's policy generator. That's why I put it here. Much more intuitive to use. There's also an IAM security assessment tool. There is AWS Access Analyzer that is a service from AWS, but this gives you a little bit different take on it. It's more focused on the actual policy itself, not the user utilizing the policy, which is really what Access Analyzer is. So those are two really nice tools. The security assessment tool basically produces an HTML report that could be sent out to people and run on any policies in your environment or any changed policies to make sure that they're not violating any of your rules. And now we'll start in on our main topic for tonight. So really, people need to understand and have a common understanding of what cloud security really is. And this is according to Think Wikipedia. I'm not sure. I think I blended a couple definitions. Cloud security is the protection of data stored online via cloud computing platforms from theft, leakage, and deletion. So even though it's a single sentence about what cloud security is, it actually has a lot of different meanings. While it only mentions data, it implies applications as well, because data is accessed by applications. So if you get access to an application, you therefore get access to the data. And then obviously cloud computing platforms, theft, leakage, and deletion. So those are three different kind of modes of data security. So theft would be, somebody, an attacker, a ransomware group actually taking your data out of your environment, as an intentional act. So ransomware in the last several years, and especially in the last 6 months, has really ramped up, where these hacker groups are not only compromising your security, getting into your networks and your systems, and they used to just encrypt your data and hope you don't have a good backup to restore from, and then they ask you for money for ransom. Now what they're doing is quite insidious by taking a copy of your data, then encrypting it and asking you for a ransom. But if you don't pay the ransom, they are leaking the data on the public internet. And that, of course, can be devastating for companies that handle PII or PCI or any real HIPAA, any kind of sensitive information at all. And unfortunately, most companies do. Everybody has information about their customers. So that's already a pretty sensitive set of data. And that's why regulations such as GDPR and CCPA and things like that have become more prominent in the world to try to protect people from these type of things. So you could say theft is the active stealing of data, where leakage is more of a passive escape or exfiltration of data by misconfigured S3 buckets or CloudFront distributions. There's a ton of ways that systems can be compromised and data leaked. And then deletion is unfortunately something that is really targeting the malicious actor, the bad actor on the inside of your organization. They would a lot of times just delete data. It might be data about them they're trying to delete, personnel records or stuff like that, or it could be data on other businesses. Who knows? But what it is more of an inside job, if you will. So you really need to protect against a lot of all three of those kind of dimensions of your data access. Somebody asked about corruption, and I don't think corruption is really, as in data corruption, is really considered to be a part of cloud security because it's a unintentional act of generally of a piece of software, a system that is has a bug and has gone haywire and written some bad data, or a glitch in the hardware that corrupts some bits as it's hitting the disk. That would be kind of more covered in a backup and DR type of scenario. Any questions on that? All right. So really, the 5 or 6 areas of security categories. So I've broken this down into the groupings of tools that are available and patterns and problem areas that you really need to consider when really implementing a cloud security practice or implementing cloud security for yourself or for a client. Identity and access management is, they're all, I can't say one's more important than another, because this is maybe drawing this as a chain would have been a better metaphor, because as with so many things, the chain is only as good as the weakest link. So if you have great everything else except identity and access management, that's where people are going to get in, and it doesn't matter how good the other areas are. So identity and access management, as we'll cover, is really all about people and even permission management. We'll go through a lot of that. And then detective controls are controls that are meant to detect real-time intrusions, data leaks, compliance issues, things like that. Infrastructure protection is dealing with and preventing the impact of things like DDoS attacks, where people just create connections to your server and don't close them, hoping to use up all the resources on your public infrastructure. and therefore taking your site effectively offline. Data protection is all about actually protecting the data directly, making sure that access is audited, that permissions are only granted to those that really need it. So it's much more of a direct rather than indirect piece of this puzzle. And then audit controls are really all about understanding what did happen. So unfortunately, you can't always stop every attack. And when an attack happens, it's very, very important to understand what happened so that you can prevent it from happening again. Without that knowledge, the entire event has been painful, costly, and damages your reputation, and you've gained nothing in exchange for any of that. So at least if you can audit your environment sufficiently to understand what the attack was and how they got it done, then you can learn and make sure you're not vulnerable in the future. And then sixth area is kind of the wild card. A lot of it depends on what exactly you do, because every different application could have different vulnerabilities. If your application uses other services external to your company, you may not realize it, but you have DNS issues. You are reliant on a DNS infrastructure that is not yours, and therefore you are subject to their security as well. And a lot of people really focus on what they can control directly, which is good, but you really also need to make sure that you reaching out of your network, say even for look up a currency conversion or look up a flight table, those things potentially could be hijacked depending on the service provider you're using. And you have to be ready to deal with that situation as well. I got a question. I heard a security data lake presentation yesterday with the intent of supporting security forensics, threat hunting, malware discovery, etc. A key principle of the talk was that all data should be maintained in the most immediate storage format, and that data retention schemes are no longer cost effective. Any thoughts on that? That is a deep question. Let's see. All data should be maintained in the most immediate storage format. So, what we'll talk about a lot, a number of these tools we'll see tonight are a great start to begin your kind of journey to a secure cloud. Many people talk about your journey to the cloud, but you really want to do a security journey as well. The idea here is for specifically audit controls, yes, you need to keep them accessible, and archiving them is part of that. And archiving application logs, somebody was just asking about archive logs, is unfortunately a somewhat costly, depending on how much logs you generate, and painful thing to do, because in many enterprises, you've got many different applications and they may not share common log formats. So you end up having to do basically ETL or format translation on your logs if you're not careful, so that you can do a centralized logging mechanism. If you look at the new term is newer term, it's been around for a few years, is SIEM, SIEM, and it's basically security incident event management. And what that's doing is looking at specifically application logs, access logs, network logs, and determining based on patterns, some MI or ML, statistical analysis, if things are different than they normally are. Excuse me. And that's become a very big and valuable pattern in security. because there's a lot of validity to how your systems are used in a kind of a, you've got your 10,000 customers, 100,000 customers, whatever it is. Statistically, their usage patterns of your products are generally going to be somewhat similar over time. If you measure your usage patterns over a couple of years, you'll see that different times of year and different days, different hours of the day, they'll all be somewhat similar day over day, week over week, year over year. And finding anomalies in that access pattern is actually valuable and telling as to what's going on. So, and the other problem is you've got such a volume of logs that there's no way a person could understand the amount of data being presented to them. So that's why a lot of these systems have been coming up in popularity on automatically processing these logs. So kind of where I was going to the original question was, yes, it's important to keep that data available generally for forensics after the event has occurred. And you'll see there's some tools that AWS provides for doing that and helping you be more effective and quick. So as we were talking about, you've got identity and access management for the categories again, and it's really managing authentication and authorization to resources. And most people think of that as people. You know, how does Joe user get access to what resources in my cloud environment? It's also how does application X get permissions or access to resources in my cloud environment, whether they're other applications of mine or the cloud providers managed services. You need to make sure that you don't just grant an application all permissions to do anything. A lot of this is about reducing not only the attack surface, your vulnerabilities, but reducing the damage that somebody can do once somebody gets into your system. As AWS has said for many, many years, things are going to crash. Plan on your system crashing, plan on failure, because it's going to happen. You also need to plan on intrusion like it's going to happen. And that helps you have a mindset of making sure that, okay, so say somebody does get in, how do you limit their ability to do damage once they do get in? For example, this Fortune 250 client I'm working with is implementing a container-based management system. And they had an on-premise container-based management system that was not particularly secure. It did not enforce security, any kind of security between container instances running in their environment. Meaning, if you deployed 10 containers with application A and 10 containers with application B, all 10 containers in each application could talk to any of the other containers of either application. So if in theory somebody got access to one of those containers, they could reach out and contact 19 other containers. And when you're talking about 400 different containers deployed, you've got quite a vulnerability there of somebody that does get into your system. So if you move to, and they're moving to more modern container systems with service meshes that provide policy-based access, mutual authentication, things like that. Even if somebody does get into one of your containers, you have very much reduced their ability to do damage once they do get in. I'm sure that most of you have heard of zero trust. And it's, again, it's been around for a very long time, zero trust architectures and policies. And it's becoming more and more prevalent and popular these days again, because what it really says is even in your own network, no one resource or service or container application inherently trusts another without some kind of proof, authentication, identity validation. So that's where a lot of these systems are going to, especially in container-based systems, because of their rising popularity as well. So back to identity and access management, it's not just for people, it's for applications as well. You want to make sure when you're, like I said earlier, calling out to an external service that they are who you think they should be, and they should be validating that you are who they think you should be as well. Detective controls identify existing vulnerabilities and activities as they are happening. So there's some very powerful tools to monitor network activity and specifically, and then access trends, infrastructure protection. Primarily that is DDoS, malicious web traffic, things like SQL injection. Anything that comes in from the outside, you want to make sure you're protecting against. Data protection, again, looking at the three facets of somebody trying to actively steal your data accidentally leaking, or an internal bad actor trying to exfiltrate or destroy your data. That's where this data protection comes in, with automatically discovering the presence of sensitive data. You'd be surprised how many companies don't know that this new application they just developed puts sensitive data on their not so encrypted S3 bucket. Another one that's very big here is application logging. This enterprise I consult with has a big investment in looking at data that comes through application logs, because developers tend to log stuff that they're processing, especially when an error occurs. And a lot of people don't think about, well, okay, I was processing this credit card. I got an error processing the card, so I'm just going to log everything I got. Well, now you've just persisted your credit card information, which is a violation of your PCI compliance. Data protection also talks about encryption of your data at rest. Most people, I'm sure, are aware of encrypting your traffic in transit, so using TLS, SSL or TLS, HTTPS traffic. But a key piece of that is encrypting it while it's at rest or on disk. Audit controls, like we talked about, securing your audit logs. Best practices from AWS indicate that in an enterprise architecture, you have separate audit logging accounts that no person has access to, that only systems can access, at least in a read-write capacity. People can only read the data, and then it's automatically handled via life cycles. The network security is points of presence, firewalls, intrusion detection, intrusion prevention systems, and private connectivity. All those things add up to keeping your traffic off the internet. While the internet is the thing that enables so much business, the internet was also built over the last, I guess, 32-ish years. And it is literally a combination, a conglomeration of different companies providing more or less free access to this data traveling across what's known as the internet. Unfortunately, what that ends up meaning is that while I might be sitting here in Denver trying to browse a website, that website could be in Boston, it could be in Brazil, it could be in England. So I'm going to traverse 2, 3, 4, 10 different network providers' infrastructure in getting that traffic between me and that web server. And that means there's 2, 3, 4, 10 possibilities for data to be intercepted. Another question was, does AWS support policy-based firewall rules where you have groups of users tied to firewall rules? Not directly at this time, as far as I'm aware. AWS, is growing and changing so fast, they tend to make a liar out of me almost every month. But firewalls are generally not tied to users. The way you would do that is through the use of VPNs. You could VPN. I could VPN into a cloud VPN, and that would then put me on a network, and you could have a firewall that is associated with that network. So it's an indirect and not simple way of doing it, but that's the way you would do it. All right. So diving into the identity and access management a little bit, for best practices, complex passwords. I mean, besides humans, passwords are the weakest link in any security chain. I'm sure everybody who's been around has seen password dumps. There's a great website everybody should check called Have I Been Pwned? And you take out some vowels in there, and I think it's PWND. And basically what that means is, has my username and password been leaked on the internet through some of these massive hundreds of millions of people's credentials being leaked in the past? So what they do is they allow you to put in your username or your email address, and it will tell you how many times that email address or username has been leaked on the internet. So very valuable. If it's been leaked more than a couple times, then you really should think about changing that. But passwords are the worst part of any person's day as far as using and having passwords and having to remember passwords or write them down, or even now using password managers are really getting a lot better. But still, they are, if you look at the time it takes to crack a 12-letter password is relatively trivial compared to a 20 or 25-letter password. And while a 20 or 25-letter password is not very easy for a human to understand or remember, it is orders of magnitude harder for a computer to guess, because you've got the math just makes it that much worse. So I cannot suggest long enough passwords. While I don't require users to have anything more than 12, I typically run between 31 and 39 characters for most of my passwords that I care about. And then within permissions, the least privilege permission model is extremely important, because again, if somebody gets into a resource, let's say they get into an EC2 server you have on the internet, and that EC2 server has a IAM policy or role associated with it that gives it more permissions than it needs, you've just given a hacker more permission to go do more damage in your environment. So it's a very, very important and painful thing to deal with developers that don't know what permissions they need or want when they come to you and say, hey, I need a role for this. A lot of the DevOps model, which I like and hate at the same time, says that developers aren't really involved in deployment or running. I know DevOps has a lot of meetings. A lot of people say it's the same team. There's, I guess, older models that are not traditionally what you would call DevOps, where you try to keep the developers away from having to know about the infrastructure. And that also means having to know about their runtime environment, and that also means permissions. So I do work with a client that their developers they know that their code's being deployed to AWS, but beyond that, they have very little knowledge of AWS, and they have no way of knowing what their permissions they need are. So it becomes a battle of friction, and how much friction can you eliminate while maintaining a least privilege permission model. And what that really means is, in your IAM policy, don't use stars. When they need access to a bucket, name the bucket in the IAM policy. Don't say every bucket in the account they have access to. If they only need access to a folder within a bucket, put the folder in there. So it's really giving them what they need to do the job, but nothing more. And another question is, does AWS support policy-based firewall rules when you have groups of users tied to a firewall rule? Oh, I think I answered this question. I'm sorry. Yes, I did. So password rotation, passwords being weak and leaked and reused, don't, make sure that they're rotated on a regular schedule. A lot of compliance regulations force rotation depending on the environment, whether it's HIPAA or PCI or CPNI. So that's always a good thing to do. And again, if you're using very long passwords in a password manager, it becomes less and less painful to do. Some of the password managers even automate the task of changing your password for certain services. Like I know 1Password allows you to automate the change of your AWS password, for example. Then multi-factor or two-factor authentication. Another thing that's become very popular, but another thing that has issues of its own as well. Initially, a lot of MFAs were based on one-time codes. You go to log in, it sends you a text message. Amazon, the shopping site, does this, and you type in the text, the code, and you're all good. And for certain things that may not be too bad. But it is really not hard to social engineer your way into stealing somebody's SIM card out of their cell phone. And I don't mean physically. I've actually witnessed this at a company I was contracting for a couple of years ago, where the CEO's phone was SIM jacked, meaning a hacker convinced their cellular provider, the CEO's cellular provider, to reissue their SIM card because supposedly the CEO had lost their cell phone. So they need a new SIM card. That card is issued to the hacker, who then uses it to send text messages coming from the CEO's cell phone. And both the VP of marketing and the CFO were messaged in ways that said that this invoice that didn't exist needed to be paid in this manner to this account. And it almost happened. It was caught before any damage was done. It's a very expensive hack because you have to put a lot of time into the social engineering. You have to understand who the right contacts are of the person you steal their SIM code. You have to understand what their cellular provider is, although that's not too hard. So it's expensive, but if it's successful, it can be very profitable. Good, but not great, is mobile phone-based authenticator applications. Okta has one, Ping has one, Microsoft, Google, they all have their own version, and they're relatively good. But if somebody gets your phone, then you can lose it that way. And there are a couple, because your phone is a computer and you can install different applications. There have been applications published to both the Apple and Google Play stores that their intention was to provide a game or some service, but their underlying action was to try to steal authenticator tokens from any apps they had installed. So it can be an attack surface. The best right now, as far as I'm concerned, are the hardware tokens, the USB. I wouldn't do Bluetooth, but the USB based YubiKey type that support FIDO2. So at some point, I think with FIDO2, we may get to a point where passwords are a thing of the past. And I think that would be a good situation under the right circumstances. But this provides something that you have to maintain in your possession, that you have to touch to activate while it's plugged into your computer. So you're validating a few things. It's still not validating that you are the person touching it, but it is, I think that would be the next step to make this more secure. But it is a real good, much more secure than any of the other two. And then under IAM is SSO integration. So Active Directory, Okta, Ping, and many choices. If you do your integration, then what that means is you're actually authenticating, providing proof of who you are through a username, password, MFA, to only one service instead of multiple. And it's been proven time and time again, if a person has to enter username and password 3 to 5 to 10 times for different applications in their enterprise, they will most likely use that same password. And that means that if it's leaked, it will be shared across all these different applications that have various different authentication models and security of those models. So having a good single security authentication point really increases your security posture. Another question about using 1Password MFA. I am not such a fan of 1Password MFA because basically your password and the MFA are stored in the same location. And that just gives a quicker attack surface to an attacker. If they get access to your 1Password, they have your username, your password, a URL, and the MFA, and that's all you need. So to me, that's not the ideal situation. I would rather have a separate physical device that is my MFA. As I was saying on SSO integration, fewer passwords means less reuse. Reuse across many different sites, applications is really the biggest problem that's out there. Then AWS Access Analyzer helps maintain your least privileged model, which is really a big benefit because, during development, everybody's in a hurry and wants to get their jobs done. Maybe you have a less strict privilege policy during development, and users are given a few wildcards or a few more permissions that they may or may not need in the end game. Access Analyzer literally monitors the permissions that they actually use over time and will make suggestions that this role or this user or this policy doesn't need this permission because they haven't used it in 3 months, 6 months, whatever the time period is. So it's a good way to kind of go back and say, we granted you these permissions, but you're not using this one or these two. Can we just remove them from you, from your role? So detective controls, next area. These are services that notify and sometimes prevent threats as they occur. Actually, I'm going to go back. I hate doing this, but I am going to tell you a story about a one-time code that I did quite a bit of research on. And the situation was a hacker used phone number spoofing to call a customer, and they identified this person as having an account at this particular bank. And they called the person on their cell phone, and said, hey, this is XYZ Bank. We've noticed some fraudulent activity on your account, and we want to go in and look, but we need to send you a one-time code to your mobile and have you tell us that so that we can legally get access to your personal banking information. And that is a valid way of proving somebody's identity in CP&I and PCI compliance models. So it's a valid thing to do, but so the hacker got this code sent to the user. The user said, "Oh, okay, Mr. Bank Representative, my code is 123456. Great, thank you very much. I'm going to get into your account now, and I will do my fraud analysis, and we'll be in touch." Everything seemed great. Seemed like your bank was on top of it and doing their best to protect you. The reality of the situation was it was a hacker that somehow found out that this person was banking at this particular brand, this bank, and knew their username, which isn't hard because 99% of the time that's your email. So you can do a little research and find out a lot about people based on their email, especially in these password leak databases I mentioned about a little while ago. And what the one-time code was not a security challenge. It was the hacker resetting the password on the user's online banking account. And the bank at this point in time, and this was a year and a half ago, I think, was a little lax, and they literally just sent a code, 123456. And they have since updated this. But so there was no indication that this was actually a password reset code, not a security challenge code. So the user happily handed it over to the hacker, and hacker got access to the user's account, stole the money, end of story. So now the banks have moved much more to a, hi, this is your bank. Somebody's requesting to reset your password. Here's your code. So at least the user has an idea that somebody's actually resetting their password instead of providing services to them. So sorry about that. Back to detective controls. Security Hub is a really nice resource in AWS, and it really is a centralized, as I say, a hub of security information. So it's findings from various AWS services that we'll be going through, and also partner applications will basically dump all the information into Security Hub so you can see it in a single pane of glass. And that's a very important thing too, because many times attacks come at and appear as different things. And if you can correlate these different aspects of an attack, you might have a better understanding that you are under attack and it's not just some issue with a piece of hardware, for example. GuardDuty, Amazon GuardDuty, is a threat and anomaly detection using machine learning across CloudTrail, VPC flow logs, and DNS logs. And I will tell you an experience I had with this. A few years ago, I had GuardDuty running on a client of mine EC2 instances. We were rewriting a big application of theirs into a serverless architecture, but they were running on EC2, running Windows Server 2008, very outdated, unpatched. Their previous company had not done a good job at keeping it up to date. And GuardDuty, I came in and turned on GuardDuty. GuardDuty popped up a few months later and said, oh, by the way, this server, our main database server that held everything from our financial records, bank transactions, our transaction records for the service that the company provided, had the WannaCry virus and was actually reaching out to a known command and control server through DNS that GuardDuty knew about and said, we've blocked that access. So a lot of these ransomware, and WannaCry got a lot of publication because it was pretty painful a few years ago. A lot of the ransomware will get installed on a server somehow and sit there and do nothing until commanded to do something, whatever the ransomware was designed to do. And the way that happens, because it's not easy or possible to get in from the outside, it goes out and does a DNS lookup and contacts a server. And it's usually some weird name DNS, just let a combination of letters and numbers. But it was known through security researchers that had captured the WannaCry executable and decoded it to the point where they knew what the DNS name of the command and control server was. So they released it within the security industry. GuardDuty picked up DNS lookup for that, blocked it, and WannaCry never was activated on this central server, which would have been devastating to my client. So highly valuable in that case. Amazon Inspector, it automatically assesses applications for vulnerabilities and exposure and deviation from best practices. Again, similar in unintended network accessibility, but this time from the outside in, remote root permissions, things of that nature where somebody either just was sloppy or didn't know that you had to lock down a server in this way. And then Amazon Detective uses machine learning to, as I mentioned earlier, conduct faster and more efficient investigations. So it's collecting a lot of data and then allows you to dive into that data and correlate different pieces from CloudTrail and VPC flow logs, DNS, and other network activity, and bring it all together in a place where it's easier to do that forensic investigation. And then, so infrastructure protection itself. As much as everybody wants to think that serverless has no servers and the AWS managed firewall has no servers, there are still servers, and you still may run servers of your own. So even if you're running, for example, AWS API Gateway, you have to treat that and think of it as if it were your infrastructure, even though it is not. And you need to protect it like it's your infrastructure. So that's what a lot of these services are really focused on, is advanced managed DDoS infrastructure, protecting your infrastructure. So WAF and Shield are services that AWS manages. Yes, there's a cost to them, but they provide the infrastructure and the software and the management of that automatically, so you don't have to manage another appliance or another system. It just does it for you. Shield comes in two flavors: basic, which is on every account, and it does a lot of the standard DDoS mitigation. So it looks for patterns of open connections and synapse and the typical ways that people try to bring down your infrastructure through TCP connections. And then the WAF, the web application firewall, is looking beyond just the connection, but the content. And it's seeing if you are having SQL attacks, SQL injection attacks, or man in the middle, or any number, JavaScript injections. There's any number of attack vectors for a web API. And it's something that you definitely need to be aware of. I read a paper earlier this year that said that web APIs, REST APIs, whatever the technology, are going to be the #1 attack vector for the foreseeable future from an enterprise perspective, because so many people do them without properly securing them. Replay attacks are very important too. If you think you don't need to validate your Java Web Token, you're definitely wrong. If you think you don't need to use timestamps, definitely wrong. Sequence numbers, you got to make sure that somebody's not replaying a series of API calls to you. The WAF also implements the OWASP top 10 and allows you to build your own rules, and then does automatic remediation by doing things like either permanently or temporarily for a period of time, banning an IP, for example. So some IP starts attacking and violating these rules, you can automatically ban them. And WAF comes in two modes. One is just observation, and one is protection. So during observation, it will notify you of the issues it's discovering, but take no action. So you're able to see how these rules will impact your systems before making them active and blocking people, because the last thing you want to do is block your actual valid customers. And then Firewall Manager centrally manages AWS WAF and managed WAF rules. As you grow and enterprises especially end up with a landing zone architecture, and if you take it to not even in the extreme, but kind of the recommended way, you will have many accounts, many accounts. This Fortune 250 customer I'm working with, I think we've passed 300 accounts in the last few years. And that becomes a very challenging situation to manage. So you don't want to make doing security harder than it already is. So the Firewall Manager allows you to set up firewall rules, common sets of rules, and apply them across many accounts. And again, it's a managed service. They manage the infrastructure. You don't have to deal with it. But the nice thing is the firewall infrastructure itself is still in your region, in your availability zone. So it's not like it's funneling all of your traffic through a single point that is then a single point of failure or a bottleneck. The firewall manager is just managing the rules and distributing them across your accounts. And then the last big piece, and it is a really big piece, because again, the internet is this mishmash of providers. And I'm not saying any provider is bad, but there's a lot of connecting points between providers that can fail. There's just a lot of different hardware. And Direct Connect provides a off internet direct connection to your network point of presence. So in Denver, there's a point of presence that my client has a fiber ring from their data center to this point of presence, and that goes directly to AWS on a private network. So it never touches the internet, which is a huge benefit for data security, traffic security. And if you can't justify the cost, because it is not necessarily cheap, for Direct Connect, then definitely do site-to-site VPN. You are writing across the internet, but you are writing with another layer of encryption. So you're getting more than one layer, and it does increase the difficulty of hacking that data by quite a bit. And then data protection itself. There's several services that work in this area. Amazon Macy. Its big thing is discovering sensitive data. It protects also, but the number of times that I've seen sensitive data sitting on an S3 bucket and nobody really even knew is overwhelming. So if you have any more than 5 or 10 buckets, you need to think about doing something to scan the data in those buckets and make sure that you're not putting data that you don't intend to out on this bucket. It helps with compliance regulations such as HIPAA, GDPR, and CCPA. For those of you who don't know, HIPAA is I'm sure everybody's heard of HIPAA. It's the Healthcare Protection Act. So that's why you have to sign 10 times the number of papers to talk to anybody about your health. GDPR is the General Data Privacy Regulation, and it was created in the EU, and it states that any citizen of the EU has the legal right, to demand from any business above a certain size information about what data they have on that person. So if you're a marketing company and you somehow have over the years collected information about John Smith, and John Smith says, what's that information you have on me? You have to divulge everything you have on them, and you have to allow them to opt out of future data collection on them. And if you are not using the data for a valid customer-provider relationship, you must allow them to request that you delete the data, and you must delete the data. And the fines are hefty. So that was done in the EU, and the US had been talking about doing it for a very long time and never really did. So California came out with the CCPA, the California Consumer Privacy Act, and it is essentially the same set of regulations for residents of California. And just like the GDPR, it does not actually mean you have to be in California or the EU at the time. You have to be a resident, a legal resident. And now what's happening, so the CCPA went into effect January 1st this year. There's, I think, 10 or 11 states that go in effect next January 1st, another 8 or 10 the year after that. So unfortunately for big enterprises, it means a lot of software is going to have to be written to collect and deal with all this data on people that request it. So it's rather unfortunate that we're going to have 20 or 50 different sets of laws that are not quite the same in the US, but that's the way it is. A question came in about, can I say a little bit about how this is priced? Macy has dropped in price by what they said was 80%. I actually don't know the pricing model for Macy. If you Google this guy, Corey Quinn, he has made a living on helping people understand their bill in AWS, and B, openly mocking AWS for any number of reasons. And he provides a lot of good information, and he's quite funny. He's very sarcastic. So understanding a bill with AWS is always a challenge. And unfortunately, I can't remember every pricing model because they vary quite a bit. I think it's QUINN. I could pull it up here. Yeah, so it's COREYQUINN. His Twitter handle is QUINNYPIG, and he's got a blog and a podcast. I think it's called Screaming at the Cloud. It's entertaining and informative, so worth a read every once in a while. So Macy's, decent service for understanding what you have and protecting it. Yes, last week in AWS is his blog. So KMS, AWS KMS, is their key management service, and it helps you manage encryption keys. And it allows for auto rotation of these keys and termination of the keys. And one nice thing is you could potentially have a situation where you've shared an S3 bucket that's got more than one KMS key associated with it. You can actually provide a KMS key every time you put a file onto an S3 bucket. And only a subset of your users who have access to the S3 bucket itself have access to that specific key. So you get kind of a two-level granularity control on who could actually decrypt the data in that S3 bucket. Say for some legacy reason, you had a whole bunch of files that were in one folder. You can't move them to a different bucket, and there's a group of users that need access to some of the data and this very small, highly secure subset. You can give them access to both keys, let them decrypt every piece they need, where the general population only has access to the one key that gives them access to the less sensitive data. So there's a lot of flexibility you get from using KMS. And then the certificate manager, I'm sorry, about KMS, there's also, usually with several of the services, there's multiple encryption options. Like S3 has S3 SSE, which is kind of their built-in server-side encryption. And then you can use S3 KMS, where you create the key and manage it yourself, but it's still a key that is created by AWS. And then you can use CMKs, which is customer managed key, where you literally upload the signed key from DigiCert or whoever you want into KMS, and it manages that for you afterwards. You do pay more for customer managed keys, and you lose auto rotation since it can't regenerate the key on your behalf. I have not found yet a use case for doing CMKs, the customer managed keys, because even in that case where you're generating the CSR and doing the signing using a different party, you're uploading the private key to AWS. So in either case of KMS keys or CMKs, they have the private key. So I don't see a big difference there. The certificate manager, similar for free SSL and TLS encryption keys for some services. It does not provide you the ability to get at the CSR or the private key, but it will provide the key for certain services. Like you can create a cert and then use it for your public facing load balancer. So if that's where your web traffic comes in, your browser will get the green checkbox, green lock, whatever the browser you're using is, because AWS's certificate authority is trusted. So there's a real good usage there. You can use it in CloudFront distributions for more static content, API gateways. There's a number of services you can use it for, but not EC2 directly. Because EC2, you're running your own Apache or Nginx or whatever server, and you don't have access to the private key, you can't install it on the EC2 directly, which is probably fine because you really should be putting a CloudFront or a load balancer in front of it. And certificate manager, you can both do public keys and you can do private CA, which is not cheap. I think it's $600 a month for a private CA. Secrets Manager is a secure and scalable secret management service within AWS. For those of you who might have used HashiCorp Vault, it's maybe not as robust as Vault, but it has some advantages. It also does auto update and rotation, including password sync to certain services like RDS. The big value in Secrets Manager is the catch-22 of authenticating an application against a secret store. In the Vault case, I've actually had to do this. The customer wanted to use Vault. They used Vault for all their on-prem stuff. And the issue was that how do you authenticate to Vault to then retrieve your credentials to connect to your database, for example? So you've got this chicken and egg of, well, I need a secret to authenticate against Vault or whatever third-party service you might be using, but I'm not authenticated against my key store to get the key or the secret. The reason that Secrets Manager is so valuable here is because for an EC2 or a Lambda or an ECS container or any of the compute services, you can assign an IAM role. And that role will grant you access to the Secrets Manager. Then the EC2 instance, Lambda, etc., will automatically have access to secrets and be able to pull them out programmatically. So it avoids that chicken and egg situation that so often happens. And then in summary, I know it's been a long hour. Thank you guys for hanging in there. I do appreciate it. So all these tools are a great place to start. Some of the tools are better than other of the tools. There is no single tool or provider of tools that will give you everything you need. There's a lot that needs to happen with container security, scanning, source code scanning, library vulnerability analysis. All these things all need to happen. You're in an enterprise situation, you're going to have multiple providers and multiple tools to deal with different aspects of security. And it's been very interesting. During this COVID-19 pandemic, there's been a huge, gigantic increase in the number of attacks, especially on home networks. So if you think about it, everybody here working in IT most likely has been sheltering in place, staying at home and accessing corporate resources remotely. Well, that's great. We're very fortunate and lucky to be able to do that and continue working. But it's been very widely known and very easily taken advantage of these ISPs routers. Generally you're going to get access to a Ring doorbell or an Amazon Echo or a TV, and maybe you can do some creepy things or whatever if some hacker were to gain access to your home network. But now it's a whole different ballgame because your laptop, your computer, all these access to resources is now sitting on this less than ideally secure wireless network, most likely. So what's going on is these hackers are just pummeling people's Wi-Fi networks, trying to get in, and a lot of times it's not that hard. There are tools out there. There are even ways to install viruses on some of these ISP routers. It's not a great situation. What I've done, because I'm in security and it matters to me, is I've installed a second highly secure wireless network behind my ISP's router. So not only would somebody have to get into my ISP router, which I have made sure is as secure as possible, but I then have a second router that uses encrypted DNS, for example, has a different SSID, a different key. I have a 31 character password on that wireless network. It is not broadcast, so you can't see it. You have to know it's there. So even if somebody were to get in and it's hardwired to my ISP router, even if somebody would get in, they would see that there's this device on this IP address, but there's a whole nother level of security they would have to break to get in, even to get to connect to my corporate laptops. And that goes right into the next piece, which is employees' personal computers should never, in this, again, zero trust, never be trusted. And I'm sure this goes without saying for a lot of people. But my enterprise client, they issued me a laptop. Yes, it's an expense. Everybody gets a laptop. Everybody gets VPN access. But it is far less expensive in the long run than allowing somebody's PC who's, 12-year-old kid got on the internet and downloaded some game that's actually a piece of malware and is spying on all your keystrokes and logging them. So when you log into your corporate VPN on your personal computer, now the hackers know your username and password. So basically, a lot of these hacker groups are looking at this pandemic as a super highway to enterprise corporate networks. Another piece is the enterprise doesn't have any control over what's installed on that laptop. My enterprise laptop is painfully difficult to get software installed on, to do anything that a typical user might want to do with their laptop or their computer, but it's highly secure. And that's got to be, unfortunately, one of your top priorities. And then sadly, people are also one of the weak links in security. And we as people that are doing security work need to help people be more secure, dealing with passwords that aren't weak, dealing with software choices that don't expose you to vulnerabilities. Another question that came in, what do you think of using AWS Workspace instead of issuing a physical device? That is not a bad solution. It is not a cheap solution. There is some latency. I actually did a proof of concept with a customer where we were doing 3-dimensional geospatial editing from LiDAR data collection in a workspace across the internet, and the performance was acceptable. It's just not a cheap solution. It's hundreds of dollars a month to get a good workspace set up. I have another client that is considering workspaces as a replacement for their existing on-prem VDI infrastructure, their virtual desktop infrastructure, for their cloud environment. Because the good thing is the communication between the device and the workspace is non-standard and isn't easily, in theory, hackable. You still have to worry about the device that's running the client, because there could be things installed on that device that would be nefarious, like even screen capture viruses that could capture data coming off the device, even when running in workspace. So it's probably not ideal, but there's always going to be trade-offs. And that's kind of why I had that 6th box there, is it really depends on your situation. Some situations that might be a workspace might be a better solution than a VPN and a physical device, and others it may not. Kind of depends on your needs. And that is, I think, pretty much what I had for tonight. Any questions, comments, thoughts? All right.
That was awesome. Thanks, Mac.
Oh, you are welcome. Glad to do it. Thank you very much. I will post a PDF of the slides to our Twitter and the Meetup page. And I'll also post a link to the video once I get it uploaded. We'll take a few hours to get that done, but it will happen. That is one benefit of doing everything virtually. It's so much easier to get good recordings of the sessions. And I would like to thank you all again for taking your time. And I will add you to the Slack channel. Thank you again. I'm going to stop recording, and you all have a good rest of your night.